Dear students, a warm welcome to online session. Now, in this session, we discuss about Unit 3 concepts, cloud and distributed computing. The topics to be covered in Unit 3 are listed 7 categories here: cloud platform architecture, architectural design, security levels of cloud, and service-oriented architecture cloud, message-oriented middleware cloud. So these topics are covered in Unit 3. After completion of Unit 3 topics, the student will be able to demonstrate knowledge on cloud architectural design and various cloud service models and cloud security. After completion of the course in Unit 3, the student will be able to demonstrate knowledge, gain knowledge on cloud computing, architectural design models, service models, and security in the cloud. In this session, let us discuss the topics in this session are cloud computing service models. Cloud computing service models we will discuss in this topics, which is highlighted in red color. Coming to the introduction of cloud computing services, over last 20 years, if we consider the economy in the world rapidly, means very fastly, moving towards from manufacturing sector to service oriented sector, which means that many industries from past 2 decades means past two decades means past 20 years, from past 20 years onwards, the world economy has rapidly, very speedily moved from manufacturing sector to service oriented sector. Now here focus on service oriented sector. What is service oriented sector means? Cloud is one of the best example for providing services to the end users with the help of service providers, cloud service providers. So almost every industry moving from manufacturing to service oriented analytics. It is one of the main advantage for gain some implementation in the upcoming years. If you consider the economy of United States in the year 2010, almost 80% of US economy was driven by service industry only, service oriented only. So 80% of industries running in service oriented in 2010 in US United States. Only 15% still they are running their industries in manufacturing sector. A little bit percentage, that is 5%, only 5% of industries are running towards agriculture and some other areas. It seems to be the economy of US based companies are mainly deals service oriented operations, almost 80 plus in the year of 2010. Now it is past 85% in present year 2020. I am saying cloud computing is one of the very interesting topic. Nowadays, the cloud computing benefits the service industries with the help of business-oriented technologies. Cloud services will boost up the business. It is providing huge demand. There is a huge demand for cloud computing. Why? Because many business-oriented software companies are moved towards service-oriented business. So all the businesses nowadays moving towards the service-oriented. So cloud computing is required for all business to run any business. So many businesses will depend on cloud computing service-oriented sectors. If you consider in the year 2019, 2009, not 19, the global cloud service market reached more than $17 billions, more than $17 billion in the year 2009. If you consider, it seems to be how the cloud market will be placed. So where is the market of the cloud? So 80% of the market will be in the cloud only. 80% of the businesses will looking for cloud services nowadays. So that's why cloud computing is a huge demand nowadays in future also. Users or end users can access means they can touch the services over the cloud by connecting through the internet. Users can access and deploy cloud applications from anywhere in the competitive market or world at very low cost. It seems to be here we can focus on two terms. One is access, another one is deploy. Deploy means that the user wants, the user can deploy his own material or his own cloud, his own applications over the cloud. Users can deploy applications in the cloud. Whenever the user required the hosted clouds, the hosted information in the cloud, simply the users can connect the cloud and access the data over the cloud. So the user can have two operations. One is accessing the data and deploy the data over the cloud. The user can deploy the data into the cloud. The user can access the data from the cloud whenever he required, wherever he required in the world at very competitive cost. So that's why cloud computing is one of the very important technology nowadays. Major business sectors are depending on cloud, and many industries are moving from manufacturing sector to service oriented sectors with the help of cloud technology. In future also, there is a huge possibility of utilizing the services of the cloud by many software companies or many industries. The concept of cloud computing has evolved from different computings. We know only what is cloud. And before cloud, there are various computing terminologies like cluster computing, grid computing, and utility computing. What is cluster computing? Clustering is nothing but a collection of servers, not a single server, a collection of servers which are combined together that can be placed over a network is called as a cluster. And the grid is also a computing methodology, and utility computing is also one of the computing. Utility computing benefit is each and every server, each and every machine which is connected to that computing mechanism is fully utilized the services 100%. That means that every machine is in the working mode only. None of the machine will be in the idle state. So the cloud computing has evolved from different computing techniques like cluster computing, grid computing, and utility computing also. Here, cluster and grid computing uses computers, not single computer, many computers. Cluster and grid computing uses many computers in parallel at a time. In parallel means at a time. Why they are using? Why cluster computing and grid computing are using a set of computers in parallel to solve very huge problems or very novel problems. So that means that if you want to solve any novel problem or if you want to solve a difficult problems, use the technology or computing is cluster computing as well as grid computing. In both computing, a bulk computers will run in parallel mode to solve the problem of any size. If the problem is big, grid computing will divide the problem into some number of small grids and assign the task for each and every grid. So parallelly, all the grids will work together and the work will be easily solved. So that is the grid computing. If the problem is very big, if we apply cluster computing for solving a big problem, so based on the traffic or based on the capacity of the problem, so the size of cluster will be automatically scaled down or scale up to solve the problem quickly. So scale down means number of servers are less, scale up means number of servers are more. The utilization of servers or capacity of the servers will automatically scale up or scale down based on the traffic imposed on the servers. Next, move to utility and software as a service. SaaS is a software as a service. This is one of the cloud service model. Here the utility and software as a service provide some computing resources as a service with the notation of pay per use. Pay per use. That means that software as a service provides some computing resources to the customers by taking money on the rental basis. Software as a service is nothing but you have an application with you. You have an application with you. But to run an application, you need one software. There are two options. You want to functioning that application, you need to purchase the software or you need to take the services who are offering the software. Either go for rental, go for purchase it. So here, the cloud providers will facilitate the end users to provide the required software, application softwares which they are hosted into the cloud. Whenever the customer or end user requires, he simply provide or enable the access to that particular person or end user on pay per use or rental basis only. Cloud computing is a high throughput computing, very important term. HTC stands for high throughput computing paradigm, whereby the infrastructure provides a service through a large data centers or servers. We can call a cloud computing is a HTC paradigm. HTC means high throughput computing. That means that never fail. Success rate is very high. The failure rate is very poor. High throughput computing is nothing but the success rate is very high, almost 99.99% success rate. So that's why we can conclude that cloud computing provides very security. Cloud computing, the applications which are hosted on the cloud computing never fails because cloud computing is a high throughput computing. The cloud computing model enables users to share access to resources from anywhere at any time through their connected devices. So that means that cloud computing models giving permission to the end users to access the resources which are available in the cloud, which are maintained by the cloud, to the end users. That clearly I can say that there is a cloud and here an end user. The end user is having application. He wants to run the application through a software. The end user wants to run an application through a software, but he is not having licensed software. He cannot bear also. In this case, what he will do? He need one cloud computing service provider who will provide the software to run his application. What he will do? He can search the cloud providers who are available in the market, provide the related software who is providing. Just communicate to the cloud providers. What the cloud provider will do? Will the cloud provider will provide or enable the access, the utilization of the access of the software to the end users. What the end user will do? The end user will connect it to the cloud through his application which is developed, and by through the whenever he connected his application to the cloud, to the internet, so whatever the software is available, that software will be fully utilized wherever he required, whenever he required, by paying money on a rental basis. So that means that the end user is accessing the software as a service by paying monthly amount to the cloud providers. Let us compare the differences between various computing over here. There are three different computing listed over here, namely centralized computing, decentralized computing, and finally distributed computing. These three are considered as a computing techniques. Now let us see the difference between these three computing technologies or techniques. Now consider the first computing technique, namely centralized computing technique, in which in which in centralized computing it contains only single central point. It contains or it will maintain a single centralized point or node All the remaining nodes which are connected, well connected to that node only. That means that take a server machine and take many client machines. All the client machines which are interconnected to the server only. So whatever the operations can done by each and independent or autonomous computers, the data finally stored into the centralized machine. So here the operations can be done and operations can be stored in a single centralized machine. So that means that limited scalability. There is a limited scalability and there is a possibility of hacking the server very easily. We can hack the server. Why? Because here we are maintaining only one single server. So all the client data will be stored in a centralized server only. When the hacker wants to hack the data, hack the server, he can easily hack the data into that one. And one of the drawback of centralized computing is if the server machine fails due to some reasons, the remaining machines or nodes, external nodes or client machines may not functioning properly. Why? Because here all the client machines are internally connected to the server only. When the server machine fails, the remaining nodes may not be functioning, due to which the operation will be stopped suddenly. So to overcome the problem, we are not recommended that centralized computing is not secure and centralized computing is not suitable for large scale industries. Why? Because it contains a single point of failure by the design. When the server machine fails, the entire network will fail. It contains bottleneck of the design. Bottleneck of the design means only one single entry. Limited scalability. Controlled by a single entity. Single person can manage the server. And hackers may destroy the data very easily. And the infrastructure also not recommended. So centralized computing is not safe for. That's why the development will move to decentralized instead of going for centralized. So in the decentralized, there are different centralized networks which are interconnected, are placed in different remote places and which are interconnected together through the network, wide area network, that is called as a decentralized. Decentralized is nothing but a collection of centralized missions, centralized networks, which are remotely hosted in different remote machines, different remote locations, which are internally connected together using WAN, wide area network, is called decentralized. So in the decentralized is also another computing technique. So this is far better when compared to the centralized computing technique. Now this computing is moved to distributed computing. So distributed computing is one of the familiar computing technique in which various nodes are which are interconnected together from one node to another node in a well connected network remotely, that is called as a distributed network. So in the distributed network, there are many points of failures by the design. Suppose consider here these bubbles are considered as a computer machines. All these computer machines are well connected together to a network like LAN and WAN. If one computer is not functioning, if more than one computer is not functioning, the entire operation may not be disturbed. Why? Because the traffic over the network will distribute it to another machine. If one machine is not functioning, the traffic will divert and it will move to another machine and the operations will be successful. Operation may not be failure during the during the working mode. So here, so it is very difficult to hack the device, to hack the distributed computing network. Why? Because the hacker may not know which device he has to hack. Why? Because the data is not stored in a single machine. The data will be stored in all the machine, and we cannot say in which machine the data will be stored. So that hacker may not be able to identify which device through which device he wants to hack. So the possibility of hacking the network distributed computing is very low. So it is very difficult also. The information leaks are less likely and much smaller in this one. So there is a possibility of leaking is very less in the distributed computing. So finally, I can conclude that if you compare centralized computing with the decentralized computing with the distributed computing, and it is one of the best computing when compared to the remaining centralized and decentralized computing. In this chapter, we will discuss about cloud deployment models. There are different cloud deployment models, namely public cloud, private cloud, and hybrid cloud. These three are cloud deployment models. So once you observe the difference between public cloud, private cloud, and hybrid cloud, the end user will decide to select which cloud he has to select before hosting his services, his applications into the cloud machine. So whenever the end user want to host his application into the cloud computing, he has to select any one of the deployment model. Any one of the cloud computing deployment model he has to select. He has to select public cloud, private cloud, or hybrid cloud. Which one is best suitable for him? Now let us see the difference between various cloud deployment models in this session. What is public cloud? Public means anyone can access the data which was hosted onto the cloud can be accessed anywhere, anytime by any person. There is no restrictions over here. So that means that public cloud. A public cloud is built over the internet and it can be accessed by any user who has paid for the services. And public clouds are owned by service providers. Service providers means cloud providers and are accessible through the subscription only. Suppose, for example, let's just consider an example. AWS, Amazon Web Services, is a cloud service provider. Amazon Web Services is a cloud service provider. So the Amazon Prime is an application. Through Amazon Prime applications, the users can access the entertainment channels which are providing or hosted over the cloud by subscribing monthly or yearly. If you want to watch Amazon Prime videos through the cloud, the end users need to subscribe the cloud services to the cloud service provider Amazon Prime videos by monthly paying or yearly paying subscription. Once the subscription over, he has the privilegation to access the data, to access the videos or entertainment channels posted into the Amazon Prime cloud. Some of the well familiar public clouds are listed here, namely Google App Engine. Google App Engine is one of the familiar public cloud. The Google App Engine will provide some services like Gmail. So Gmail is a free service they are providing. It is a software as a services they are providing. So there is no restrictions on the accessing Gmail. So every end user can create his own account by law by creating Google accounts publicly. So there is no restrictions at all, no need to pay the amount also. So that means that Google App Engine is a public cloud. Anybody will access Google App Engine or Gmail also. Another one is Amazon Web Services. Amazon Web Services is also public cloud only. It is open to all. So some of the well familiar Amazon Web Services applications are software as a services are available like Prime Videos, but Prime Videos is not free. So the end users need to subscribe for watching the videos through the Amazon Web Services. And next one is Microsoft Azure. Microsoft Azure is also providing some operating system services over the cloud. So if you want to access any operating system, like Windows operating system, if you want to access through the cloud, so you need to connect to the Microsoft Azure cloud, and you need to access the services provided by the Microsoft Azure. But it is not free; it is also payment. User need to do some payment. Suppose, let us say a simple example. You want to do some operations with the help of licensed version of Microsoft Windows only one day, single day. Listen carefully. A customer wants to utilize the licensed version of Microsoft Windows for his business for a single day. But he has two options. One is one is either he go for rental, another one is he has to purchase the software. But there is no possibility of purchasing the software for one day. Then alternatively, he has to move to rental basis. What the person will do, he is running one business. To run his business for single day, he need one licensed version of Microsoft Windows software. What he will do is simply go for rental basis. He has to connect his business applications to the Microsoft Azure cloud, and the Microsoft Azure cloud will provide the Microsoft operating system, Windows operating system on rental basis for one day. He will pay the amount. They will enable the license version of the software to the end user or customer. Customer will access the services over the internet only one day. After that, he can leave it. So agreement will go over between the client, between the end user and the cloud service provider. So that is also considered as a public cloud, but it is paid. IBM Blue Cloud is also another familiar cloud. It is also considered as a public cloud. And well familiar one, Salesforce.com. So this is also another cloud. Salesforce.com is also one of the familiar cloud. Using the Salesforce.com, the customers or end users can able to create their own applications over the cloud in very secure and easy manner. Another one is private cloud. Private cloud is nothing but there are some limitations, there are some restrictions to the end users. Private cloud is built with the domain of an internet owned by a single organization. Private cloud is built with a domain. Domain means extension of domain name. Consider an example, khit.ac.in. That is the domain name. khit.ac.in is the domain name. www.khit.ac.in is the domain name. Who will maintain that cloud? If you want to maintain a public cloud for a organization, so the operations can be done through extension of the domain only. Some x.khit, y.khit, some z.khit. Why the extension of domain is required means only the customers who are connected to that particular organization having the privilegation or access to enable the services provided by the organizations. That's why they're providing some domain names. So outsiders are not having permission to access the services provided by the company, by the organization. So that's why there are some limitations for that. Private cloud is a client owned and managed, and its access is limited owning. Not all, only limited only services they will provide it to the end users. But always the private cloud should be owned and managed by a organization or a single person only. It is not a public. Its deployment was not meant to sell capacity over the internet through publicity accessible interfaces. That means that whatever the applications posted into the cloud, private cloud, they are not doing their services on the cell mode, cell capacity. So not for going for the public publicity and other. So they will maintain always companies or organizations or industries are looking private clouds to fulfill their basic requirements, basic needs only. They are not doing for business. They are not doing for selling their products outside. Private clouds give local users a flexible and agile private infrastructure to run services, workloads within their administrative domains only. Let us consider a architectural diagram of the functional architectural diagram with different clouds, deployment models like private cloud. This is a private cloud. This is public cloud. And this dotted block one is hybrid cloud. Here consider there are three clouds. This entire cloud shape is considered as a public cloud, and the small cloud is considered as a private cloud. And here this public cloud half part and private cloud half part will be combined together, and we can kept in a dotted lines, that is considered as a hybrid cloud. Why we name this one as a hybrid cloud means hybrid cloud is a collection or a set of public cloud and a private cloud. So hybrid cloud will utilize the services of public cloud services and private cloud services. That's why we can consider this entire part will be considered as a hybrid cloud. Whereas private cloud means it is a small cloud, only one cloud will be hosted in the public cloud. Why? Because it is having some limitations. Only the services will be operated by their customers only, which are working employees or end users who are working in that organization. So that's why only IBM RC2 is one of the example for private cloud. Consider a public cloud. There are a couple or huge number of cloud providers which are hosted their services over the cloud in a free access. So that's why they can provide the services to the end users with the free of cost. Some of the well familiar public clouds are namely Microsoft Azure, Salesforce.com, Google App Engine, Amazon Web Services, and IBM Blue Cloud. These are different cloud service providers which are hosted their services on the cloud public mode. So users want to access the services provided by the clouds whenever they required, wherever they required through the internet, they can host the services and they can access the services. But there are some limitations for the private clouds. Only the end users who are connected to the particular organization, they can have the permission or privileges for access the cloud. Whereas a hybrid cloud, it is a combination of both public services and private services. That's why we can consider as a hybrid cloud. So here let us consider a simple example, architectural functionality, how it is happening in the real-time market. We will discuss here the functional architecture and the connectivity of cloud available will seen in this diagram. First, the end users are the users. Here there are three users. One is highlighted in yellow color. Another one is blue color. Sorry, green color, another one is some red color. So these three colors are considered as three different cloud users, end users. What is the duty of end users? End users will connect to the cloud through the internet. The end users will connect to the cloud through the internet. Here the end user connected to the Salesforce cloud, another end user connected to Google App Engine, another end user connected to IBM Blue Cloud. So the end users will connected to the available public cloud through internet only. They have some privileges. They can host the applications over the cloud, or they can access the services offered by the clouds whenever they require, wherever they require. Once the cloud users well connected to the public cloud, and the end users are other public clouds which are connected to these clouds through the internet only, through the internet only. That whenever they connected to the internet, one application program interface will be created. That is a platform. They need one platform. For platform is also set up for that. So many end users or cloud users will connect it together. So all the cloud users which are well connected, those are will be kept in a queue mode. That is as a cloud service queue mode, and the they want whatever the data, whatever the applications the cloud users post onto the cloud, they can be kept in a queue mode, and that the applications can be stored in a cloud storage through one machine, that is considered as a server clusters, that is considered as a VM, virtual machine. So this entire part is considered as a data center. Data center is nothing but a collection of virtual machines and cloud storage which are considered as a data center. So that means that finally I can conclude that an end user connected to the cloud through the internet, and they can host their applications onto the cloud through the internet. So whatever the application they hosted, those applications will be kept in the queue, and the applications will be stored into the cloud with the help of the virtual machine only. Whenever the end user want to access their their hosted information over the cloud or from the cloud, simply he can retrieve the data from the cloud whenever they require or wherever they require. That is very easily. So he is having the privilegation for connecting the cloud through the internet, different cloud deployments like public or private or hybrid only. Next, we discuss about hybrid clouds. What is hybrid cloud? hybrid cloud is a combination of both public and private clouds. So sometimes customer or end users want to access two different clouds based on their requirements. At that time, they need to access public cloud, private cloud separately. So that is time consuming process. Instead of that, simply they choose or select one another cloud, namely hybrid cloud. Hybrid cloud will provide the environment like as a public cloud as well as a private cloud. So sometimes they need to access the data, they need to retrieve data from the cloud. That can be possible to the hybrid clouds only. Here the hybrid cloud provides access to the clients and the partners, networks and the third parties. So here hybrid cloud will be maintained by the third party. It will provide the access privilegation to all the network partners and the third parties. And the private clouds can also support hybrid cloud model by supplementing local infrastructure with computing capacity from external public cloud. So there is a possibility of connecting private clouds to the hybrid clouds whenever they want. Discuss with you an example like RC2 considered as a research compute cloud. It is considered as a private cloud and it was developed by IBM and that interconnects the computing and IT services at 8 IBM research centers scattered throughout the United States, Europe, and Asia. So these countries will be considered as a hybrid clouds. Now here we will conclude the difference between different deployment models of clouds like private, public, and hybrid. Over here, this PPT. The public cloud promotes standardization. There is a standard instructions while promoting public clouds. Some rules and regulations they impose for accessing the data in the public cloud and preserve capital investment. If you want to maintain a public cloud, if you want to host the data over the public cloud, some basic capital investment is required for each and every cloud service provider and offer application flexibility. So that means that public cloud means so any applications can run. There is a not platform independent. It's a platform not platform independent. Platform independent. Platform independent services they will provide. So any application can access through the public cloud only. Next one is private cloud. So private clouds attempts to achieve customization. Customization means narrowing, not elaborate, narrow, bottleneck. Your access is limited. So private clouds attempts to achieve customization and offer high efficiency. Why they are narrowing? For getting more quality, for providing higher efficiency, providing higher security and privacy for the cloud service providers. Next, hybrid cloud. It operates in the middle with many compromises in terms of resource sharing. It acted a middleware server, a middleware machine whenever we are working with a cloud, hybrid clouds. Why? Because it will share, it will act as a public as well as private clouds. Now, students, we will stop the session, today's session. In this session, we only discussed the basic concepts of cloud computing, when cloud computing started, and what is the real market of cloud computing, and how the cloud computing will be different with various computing techniques like uh, like centralized computing and decentralized computing, and how cloud computing will be different with uh, distributed computing also we discussed in this session, and various cloud service models, not service models, deployment models like public cloud, private cloud, and hybrid clouds will discuss in this session. And next session we will move to the new concepts of cloud service models like SaaS, software as a services, PaaS, platform as a services, and IaaS, infrastructure as a services. With a brief example, we will discuss in the next class. Now I am closing the session. Thank you. Thanks.